Hi, good evening.
Good evening,
Hi, sir.
everyone.
Good evening.
Good evening. Hi. This is trainer Rahul. Nice to see good number of participants here. So I'm Rahul. I'm actually, you can see my introduction here. I'm Rahul. I'm an engineering graduate. So I have a kind of 11 years experience in telecommunication domain. So today, actually, the plan was to, meet you all and, discuss some concepts of BGP with you guys. So just curious to know. Are you all from a networking background? Everyone are you all experienced guys?
Yes, sir.
Yes,
Okay.
Yes, yes.
Okay. So is this
yes,
a
sir.
is this the first time that you will be learning BGP, or have you worked in BGP earlier as well?
Yes, sir.
Okay.
I'm working with an ISP.
Uh-huh. I see. Okay. If you're working with ISP, then I think you would have a lot of exposure to BGP. That's right.
Yeah, exactly, exactly.
Awesome. Okay. That's great news. That's good to know. So, in my institution network journey, so what we're doing, we are actually conducting two free webinar sessions today. So that'll be on BGP. The webinar sessions for 90 minutes. That'll be on BGP. So after this, we can, the interested guys, you can enroll into the batches, and for further studies, you can get into our institution. So it's not like it would not generally the session would not be like I am teaching you and you're learning. It's basically both we both will be learning together. So it's not like I'm teaching and you're learning. We both will be learning. We both will be troubleshooting. I mean, we all will be troubleshooting. We all we can go through any scenario that you come up, or any topic that you know about. We can discuss it and make sure that we all have good amount of knowledge. Okay. So we have some day-to-day plan as well with us. Okay, so let me show you the day-to-day plan which I have. So once you get enrolled, so this is the CCNP batch that I am conducting. Okay, so once you get enrolled, this would be the day-to-day plan. On the day one, I'm going to start with the introduction to CCNP and about the labs that you're going to use when you're at home, or when you want to try yourself. The labs that you're going to do will be in GNS3. So if it is in GNS3, I would also help you with that. I would go through some topics of GNS3 as well. Then we would go into some protocols, dynamic routing protocols, EIGRP, OSPF, RIP, BGP, and then we would go into some switching concepts, the security concepts, and all that, and also something related to AA, identity based networking as well. So this is actually a total of 22-day plan that we have. So we have planned for 22 days. It would be both weekend and weekday classes. So depends upon how the trainees choose it. If you want to go through it again, I'm just scrolling up so that if you want to see the topics covered. So these are the topics that will be covered. All right then. So can we can we get on with the classes? Can we get on with BGP? Are we all are we all set?
Yes, sir.
Okay, I take that as a yes. So as I already introduced, this is Rahul. So you can actually stop me whenever you have doubts, or whatever you have to ask. You can directly ask me. You can stop me and start asking. Okay. So now the topic here is BGP. So BGP is actually used. It is one of the most important topic when it comes to the internet. So it is one of the important protocol when it comes to the internet. The reason why I chose BGP is it is of that importance. Okay. So internally, when we talk about an organization, we have lot of protocols to actually get to know the network. So if there are hundreds of routers and there are many networks or many IP addresses on those routers, to know those IP address we have many internal routing protocols. Okay, interior gateway protocols like OSPF, EIGRP, RIP, ISIS, depending upon what the company finds benefit, they use that protocol. But when you have to connect with other organization, you have one and only protocol, that is BGP. So BGP is the only protocol that will be connecting to two different autonomous system. So the I uttered autonomous system. So what is autonomous system? So autonomous system is actually a collection of networks. So autonomous system is actually a collection of networks under a single administrative domain. Say that I have a company and I have different branch office, but I will be using it, but I am the only single administrator for that. So I manage this entity. I get an autonomous system from the authority. Okay. There is a central authority which actually assigns autonomous system numbers to different organizations. These organizations should be a different, I mean, single administrative entity. So autonomous system basically is a collection of networks under a single administrative domain. Okay. As I already told you, IGPs, don't be confused with the IGP and EGPs. IGP is interior gateway protocol, which means everything that is used, all the protocols that are used in within an autonomous system are known as internal interior gateway protocols. Okay. And BGP is an exterior gateway protocol which is used outside an autonomous system, that is between two autonomous systems. Okay. That is the concept of autonomous system. So if you ask me, so where do I get the autonomous system and how does it looks like? So if I register an organization, I have to go to the central authority and get an autonomous system number from them. So we have autonomous system numbers from 1 to 65,000, 65,535. That's right. Next, moving on, we have IGP and EGP protocols. So IGP protocols, what we learned today is, I mean, we are learning EGP protocol, exterior gateway protocol. IGP protocols, the examples are, as I earlier told you, it is OSPF, EIGRP, RIP, ISIS. These are the IGP protocols. EGP protocol, one and only BGP. So we're going to discuss the basic BGP features as well. We're going to discuss the loop prevention mechanism, and also we'll discuss when to use BGP and when not to. So this is the slide. I just made the slide in case if somebody wants to write down or keep a note of something. So I just made this slide so that you can note it down as well if if any this one you want to keep a note of this, you can. So these are the routing protocols that we use within an autonomous system. Okay. These are called dynamic routing protocols. Why they're called as dynamic routing protocols? Because once we advertise them, once we enable those protocols, they actually form the neighborship dynamically. We don't have to do anything. That is why these are known as dynamic routing protocols. Now let's get back to BGP features. BGP features about BGP, it's an open standard protocol. Open standard protocol in the sense everybody can be using it. Okay, it's not strict to only particular devices, particular vendor, or particular organization. It is an open standard protocol. And in BGP, we always call BGP a path vector protocol. The reason why we call BGP a path vector protocol is because when it sends updates to its neighbors, say that it is sending a network. Okay, sorry about that. Okay, it's known as path vector protocol. The reason is it always sends the path information. Now, what do you mean by the path? So, if I am traveling, say that I have a network. Let me actually show that to you in writing. I hope you all can see my screen, right?
Yes,
Everybody
yes, we
able
can
to
see
see?
your screen. Yeah.
Okay, that's good. Just wanted to make sure. Let's say that we have autonomous system number 500, 600, and 700. What happens when BGP actually connects between different autonomous system? It usually, keeps a note of the AS path information. That is, okay, I have come in from autonomous system 500. So if I have a 5.0.0.0 network, when it reaches 600, it will say I am 5.5 network, 5.0 network, and my AS path information is I've come from autonomous system 500. Now, when the same thing reaches, when the same 5 network reaches autonomous system 700, the AS path field tells you that I have come from 600, 500. So I've come from 500 first and then 600, and the I will be here. Okay. So this is nothing but keeping a track of autonomous system numbers, keeping a track of the path information, or keeping a track of all the autonomous system numbers that I pass by. So that is why BGP is known as path vector protocol. So when you say path vector protocol, you should always remember that it is keeping a note of all the paths that it is traversing. Okay, that is known as path vector protocol. Okay, now let's go to the some more features of BGP. So when BGP, when you see that here, it also says that it uses the TCP port 179. So when I say I am actually advertising BGP on this particular router, when I say router BGP, say autonomous system 500, it automatically connects on the TCP port 179. It sends a hello message or whatever update it sends on TCP port 179. Okay, that is why we always look for TCP ports open to be open, that TCP port numbers 179 to be open for all the BGP sessions. Okay, if there is any BGP troubleshooting, we make sure that TCP port 179 should be open, because BGP updates or BGP process, BGP sessions, they're all depending upon this port number. And the metric, so when it comes to the internal routing protocol like OSPF, we have some cost which depends upon the cost bandwidth of the interface. Or when you take EIGRP, it depends upon the bandwidth and the delay, that is the k values, k1, k2, k3, k4. EIGRP depends upon the k values, but BGP depends upon the attributes in the sense there are many attributes that we'll learn in further classes. We can learn the attributes one by one, and also we can do a lab on that more clearly in the coming classes. So BGP usually depends upon these attributes to decide which path to take on, or if there are two networks having the, if there are two networks for the same destination, if there are two paths for the same destination, then BGP depends upon attributes. So there is something known as administrative distance. The administrative distance of the internal BGP, which is formed within an organization, within an autonomous system number, that is 200. The autonomous system, if there is a exchange of routes between different autonomous system numbers, the administrative distance is 20. Next, we'll talk about the loop prevention mechanism in BGP. So we have till now we have discussed about the BGP features and what is autonomous system number, what is IBGP, what is EBGP. Now we'll talk about what is loop prevention mechanism. So as I explained you earlier, the BGP protocol carries the AS path information when it's traveling. Okay. So whenever it moves through an autonomous system, different autonomous systems, it actually makes a note of the autonomous system numbers that it has traversed. Okay. Let's take an example. Let's take an example of these 5 routers here. Okay. Let's say that all are connected to each other. Okay. I'll name them as R1, R2, let's say 500, 600, 700, R3, R4, 800, R5, 900. Let's say these are the different autonomous system numbers that we have. Okay. Let's say that there is a network on R1. What is the network? It's 1.1.1.1. It's going bad. Okay. So this is the network on R1. So R1 has to pass that, say that R1 is a neighbor of R2, and it will pass that 1.1.1.1 here. So R2 has 1.1.1.1. That is the prefix that has been reached autonomous system 600 by the neighborship. Okay, when you do a neighbor and when you advertise this R1, when you advertise this route is seen in 600 autonomous system number. And also along with the route, along with the prefix, you also have the autonomous system number that it is coming from. Now let's say 1.1.1.1 is here as well on the autonomous system number 700. Then we have a note, I'm coming from 500 and 600. Similarly, when it reaches here, it has 500, 600, 700, 800. Okay. When it goes here, it says 500, 600, 700, 800, 900. Okay. The minute this router R1 sees that there is its own autonomous system number, there is its own autonomous system number in the AS path, it discards the route. So, meaning to say, so whenever a router, or in an autonomous system number, whenever a router sees its own autonomous system number, it will discard the route. The reason being, so whenever there is that particular route coming in to that same autonomous system number, we see that there is formation of loops. If you can see, the route is actually reaching the same router, okay, moving through different autonomous system numbers. So to prevent the loop in external BGP, we have this feature. Okay, what happens is AS path is the feature which actually prevents the loop in external BGP. It actually discards the route which is coming in from the same autonomous system number. Okay. as you can see here, when it sees its own AS number within the routes, it will not install that route. It will not install that route. The BGP avoid loops in network of different autonomous systems. This is actually the feature that is used in BGP to avoid the loops. But it depends. Now, we just saw in EBGP actually avoided this loop. Okay, since the autonomous system numbers are different. Okay, I was able to make a note. Okay, I was able to make a note. Okay, I'm coming from this autonomous system, I'm coming from this autonomous system, I'm coming from 700, 800, again to back to 500. Okay, since the autonomous systems numbers are different, I'm able to keep a track. But what if everything is in a single autonomous system number, that is only 500? Then there is a chance of, the route being coming back to the same router. There is a formation of loop. There is a chance of, a loop being generated. Let's see that in my further slides. In external autonomous system, in different autonomous system numbers, we are able to avoid loops as there are different AS paths. We can keep a track of it. Let's see what happens in the internal BGP IBGP. Now we have some cases noted down here. We have some uh, conditions, or not conditions, we have some recommendations. So some organizations, or if you have a small organization with less number of routers, less number of systems needed, then you may go for BGP, or you may not go for BGP, because the only thing you will be looking at is install a default route towards the service provider, and from the service provider you add a static route to your office or office router. So these are the recommendations, like when to use BGP and when not to use BGP. So most recommended is, whenever you need BGP, you should have two exit paths from your organization. Two exit paths in the sense, when you have a router, when you have an office router installed, you should have at least two exit paths, multiple exit paths. Maybe this is to ISP1 and this is to ISP2. And also your motto should be doing path manipulations. So whenever your motto is that you have to do a path manipulation and I have multiple exit paths, only then BGP usage is recommended. Otherwise, the BGP usage is not at all recommended. Okay, that is the main motto of using BGP. Using BGP also, what happens is, your office router starts getting many routes, because the BGP routing table is the internet routing table, and we have more than 1,000 routes, 100,000 routes in the internet. So if you want to use BGP, you have to be careful, and also your router should have a lot of memory resources, all that is needed. Okay, and there are some certain ways of connecting to BGP as well. Connecting. Yep.
Sorry for the interruption, right? I have a question. You mentioned something about BGP. You need to have a router with a lot of performance, right? So
Sorry?
wait, hello?
Yeah, go ahead. Can you repeat that again?
Yes, I said that you mentioned something very important about BGP, right? So how do you prevent those routes behind the internet when you are using, okay, let's say when you are using BGP for your internet in your company, like that?
That's right. So I have a network connected on my router. So how do I send it on the internet? Is that your question?
No, how do you prevent the route behind the ISP?
Okay. You mean to say, how do you prevent the routes? You have a We can actually discuss that. So we have something known as AS path prepend. Okay. We have a feature in BGP which actually says AS path prepend. with which we can actually prepend the autonomous system number to all the BGP paths. Is that the right? I mean, is that the solution that I gave you? Is that right? Because I didn't understand your question properly. So I thought you were talking about AS path prepend. Is that what you were looking for?
No, actually, what I'm asking is like, you know, you can have many routes, right? When you are dealing with BGP, correct?
Okay.
Yeah. So my question is, how do you prevent those routes in your table, right? In your routing table.
Just by the network command. When you say network 500, this is prepended. This particular route is prepended. So when I do a show IP route, I have lots of, okay, I have lots of routes in my routing table. Okay. So coming to BGP, if I have to prepend those routes in BGP, I have to go to the BGP process, first of all, by saying router BGP autonomous system number, let's say 500 is the example. Then I will establish neighbor relationship. Once I establish neighbor relationship with my neighbor, let's say my neighbor is maybe 1.2, then the next command would be the network command. Network command gives you the freedom to, prepend or advertise whatever networks you need on the internet or to your neighbor. This is the command which you use to actually advertise to your neighbor. Okay.
Okay, perfect. Thank you.
Thank you. Anybody has any questions? Okay. I take that as none. Let's continue. So we have different, thanks for the question, by the way. So we have different questions. I have, okay, that's right. This is right, by the way. IGP has more AD value because yes, that's right. EGP is considered as one hop away. That's a nice answer. Thank you for that. Okay, the different ways of connecting to the internet. We have different ways of connecting to the internet. Single homing. Single homing in the sense we have just one exit path, just like this. Let me take it side by side so that you all can see it. Single homing somewhat looks like this. This is a ISP and this is your edge router. This is ISP. So when you say single homing, you just have a single link towards the internet service provider. When you say a dual homing, you again have an ISP, an edge router, but this time you're thinking about the redundancy. What if this link goes down? I have to use this link as well. So you're thinking about the redundancy in this particular way of connection to the internet. What about single multi-homed? Now this time, multi-homing means you have multiple exit routes. You have ISP1, ISP2. Okay. You have two service providers. What if one service provider is causing a problem? Then I have to go with the second service provider. What about dual multi-homing? Dual multi-homing kind of a connection is again having multiple service providers, ISP1 and ISP2, but you again think of redundancy here. Okay. You can think of redundancy here. These are the ways that you actually get out to the internet. So it depends. So it depends which kind of path manipulation you want to do with your company and with BGP being around. So that is the usage of all these kind of connections that we have till now. So these are the connections used by the enterprise networks till now. Now, talking about connecting to internet with BGP, on the other side, we're just talking about the router one connecting to ISP, but from on the other end, we have some static routes from the service provider, from this end, we have a default route if we do not need BGP. If we need BGP and specific route, we do a neighbor relationship using BGP from router 1 to ISP. If we need the full routing table, then we establish BGP neighborship and ask them to advertise the entire internet routing table. But always remember, when you want the entire routing table, when you want the ISP, the internet service provider, to advertise all the internet routing table to you through BGP, then you should make sure your router has enough memory, enough resource utilize. I mean, enough router has all the resources, enough memory, enough processing power, because the routing, as I told you, the routes, internet routes are more than 100,000. Okay, that's about the basic features, and connecting the BGP to internet, and from the internet service provider, how the connections are done to our router, our organization. So further, let's talk about BGP neighborship. So BGP neighborship is somewhat different than your dynamic routing protocol neighborship, because we have to ourselves put in the neighbor command in this particular protocol. Okay, so in a dynamic routing protocol, you just have to say, once you declare router OSPF so and so, you just have to advertise any particular network in OSPF, and it will automatically take care of the neighborship. But here we have to manually mention, in BGP we have to manually mention that, okay, here is your neighbor, so and so is your neighbor. And also, one more thing, in BGP, internal BGP, we always, first thing to remember, I'll just write it down, manual neighbor command. Okay, this you need to always keep in mind. Whenever it is BGP, we have to put in the neighbor command manually. Okay, just an example of that, router BGP 500. Let's say these two, our routers, just taking a simple example, not to complicate much. Neighbor 1.1.1.2. Remote is 500. So this is the command that I usually use, that we put in BGP. So when I say manually, the administrator has to put in the neighbor command manually. Okay, we need to configure it manually. So let's look at some BGP neighborships. Okay, how it is formed and how does it help. Okay, and what are the BGP tables that we have. Okay, so let's go to, let's go to some labs. Before going into labs, do we have any questions from anyone? Okay, I'll take that as none. Give me a minute, guys.
I have a question in the meantime. Can I?
Sure. Go ahead.
Okay. Will you be talking about SD1 or SDN a little bit today or somewhere?
So today we are actually mainly focusing on BGP today and tomorrow. We're mainly focusing on just BGP for 2 sessions. So once we are into the CCNP tutorial, obviously it has a part of SD-WAN. So a basic introduction of SD-WAN. So in our CCNP tutorial, we definitely have two classes about, SD-WAN and its related, related technologies.
All right. Thank you.
No problem.
So, excuse me, only two
Hi,
classes
sir.
for SD-WAN?
That's right. So basically, we are able to cover. So two classes includes like 6 hours. Okay, so CCNP has in its syllabus has 6 hours of classes for SD-WAN. Not 6 hours. That is more than 4 hours. That's it. So we just have a basic introduction in the new CCNP syllabus. We just have, but we can assure you that all whatever is there in the syllabus will be covered in the classes.
Your
Thank
screen
you.
is
Okay.
blank, not able to see.
One second. I am just actually connecting you through that. Okay, just give me 1 minute. So right now, let's actually get on working with some labs. When I say labs, it's nothing but establishing BGP neighborship. First, we'll talk about uh, internal neighborship, that is within the same autonomous systems, and then let's go to eBGP between different autonomous systems. Okay. So let me go to my lab first. I'm just give me 20 seconds, guys. So I'll just switch on my screen for you. Okay. I think it should be. Let me know when you're able to see my screen. Okay. I just sharing it. Let me know once you see it.
Yeah, it's visible.
Okay. Awesome. Hmm. Okay. 1 second. I actually, let's go through the internal BGP neighbors. Can you hear me? Can you guys hear me?
Yes,
Your
yes.
screen is not visible.
Okay. Again, it's not visible. Just turning it on.
Still screen is the black. Not able to see.
Just put it on. Hope you're able to see that.
Yeah, now I can see.
Okay. Awesome. Okay. When talking about the neighborship, let's talk about the internal BGP neighborship first. I thought we can do the internal BGP neighbors. I can discuss the neighborship first. What are the scenarios of that? What are the outcomes of that? And then we can take up the lab in the maybe after that. I'll create a scenario for you guys. Okay, so I'll create a topology like okay. Let's say that we all have this in the same. Our motto here is configuring IBGP. Okay, when I say IBGP, automatically the thing that strikes in your mind is every router is in a same autonomous system number. Okay, let's say that autonomous system number is 500. Okay, AS number is 500. What we can do next is we have to establish the neighborship between these four routers. Okay, that's the task that we have. What we do initially, whenever we have any internal BGP neighbor, always the command and syntax should be router BGP 500 is the origin of BGP, is the command or syntax that allows you to start the BGP first. Okay, then you have to always, as I told you in BGP, the neighborship is always manually written. So the neighbor, next router, I have a scenario for you. Once it starts, I have it. I'll have it going for you. Let's take the IP address. Let's say that neighbor 1.1.1.2 remote AS 500 network. These are the three commands that we actually need to learn in BGP. So all that is required for us when we do BGP is these three commands. The one to start the router, one to start the BGP process, the next one is to start the to establish the neighborship, and the next one is to advertise your routes. Okay, now when you advertise your routes in eBGP, what happens when you say eBGP, when you advertise these routes in eBGP, the routes, R2 is the neighbor, R2 is the neighbor, hence 1.1 comes here. Say that I have a network connected to my LAN interface. This we call it as a LAN interface. Router to router connecting interface is known as a WAN interface. So I have a route coming in to R2. But in eBGP, the issue is it will never pass on to R4. It will never pass on to its next router. The rule is known as split horizon rule. So we're going to be talking about split horizon rule, and we'll be configuring that and seeing the routes. I have this slide for split horizon rule as well. The rule says any update sent by one BGP neighbor will not be forwarded to another BGP neighbor. This happens only in case of same autonomous system, that is IBGP. Okay. In internal BGP, an update sent by one BGP neighbor will never be sent to another BGP neighbor. That is known as split horizon rule. What happens? So you might ask me, like, okay, what happens if an update sent by one BGP neighbor, what happens if it sends to other neighbor? It keeps on sending and the same updates will come back to the same router, resulting in a loop formation. Okay. To avoid this loop formation, there is a split horizon rule which actually avoids this loop formation. Okay. The rule is made just for that, to avoid the formation of loops in an autonomous system, same autonomous system. Now, when we have different autonomous system, we have AS path taking care of that, right? We discussed initially, I just discussed with you in eBGP, we have the AS path information tracking the autonomous system numbers to avoid the update going to the same autonomous system, right? In the eBGP. But what happens in IBGP, the update sent by one neighbor will not be forwarded to another neighbor. Split horizon rule. So split horizon rule is taking care of internal BGP, IBGP formation of loops. Here AS path is taking care of eBGP formation of loops. Okay, that is how we actually that is how we actually avoid the loops. Okay, now I have a simple topology for you guys. I just have a simple topology where I can configure those labs for you. Let me start all the routers. Okay, so this is the topology that I have. I have router 1, I have router 2, router 3, router 4. Simple. 4 routers. You have the connected interface. You can see the connected interfaces also. S1 bar 0, 1 bar 0, S1 bar 1, serial interface 1 bar 0, serial interface 1 bar 1, 1 bar 0. And I have some loopbacks interface as well connected to R1. I have some loopbacks interfaces connected to R2. I have some connected to R3, connected to R4 as well. And these are the WAN interface connected to fast Ethernet interfaces. Okay. The WAN interface is 10.1.1.1 for R1. For R2, I have 20.1.1.1. For R3, the WAN interface is 30.1.1.1. For R4, the WAN interface is 40.1.1.1. Simple. Okay. And also, just to make it very simple, I have you for router WAN interface connecting router 1 and 2. I have 1.1.1.1 and 1.1.1.2. Here I have a 2 dot network. Between 3 and 4, I have a 3 dot network. Between 4 and 1, I have a 4 dot network. Okay. Just I wanted to make the configuration look simple, or the topology to look simple. So I just have taken this from the, we have a huge lab setup in our network journey. So this is just a part of it. I have just taken a part of it. I'll just show you the lab as well, what all the lab we have and how the lab is designed, how our lab topology is. I'll show you that in a while. Before that, let me start configuring this BGP and show you how the IBGP first of all is configured. So once we are done with IBGP, we'll move on to eBGP. Okay, between now I am taking that this is all configured in the same autonomous system number, that is same autonomous system number, which is AS 500. Okay, Come on, man.
Please, can I ask a question?
Sure, go ahead.
Please, when do you use IBGP?
Sorry?
When will you use IBGP? In
When
what
you're
circumstances will you use IBGP?
when you're in the same autonomous system number. So you're working for a company. Let's say that you're working for an enterprise. Okay, the enterprise has an autonomous system number of 65,000. Okay, when you have to connect through BGP to any other router in your same organization, you use IBGP, because even that particular router in your same organization belongs to autonomous number 65,000 only. Okay, that is when you use IBGP. But say that, let's say, when you are using, when you are connecting from your router, you want to connect through BGP to a different organization. Okay, different organization will have obviously a different autonomous system number. Okay, at that time you will be using EBGP. Does that answer your question?
Yes, I know, but why can't we use OSPF?
We can use OSPF. So definitely we can use OSPF. So when you say, let me actually bring that notepad. Okay, so you say that I'm connected to a different organization with a different autonomous system number. Okay, here definitely you can use OSPF as well, because the and I'll let you know the scenario as well. So I have routers, I have my branch office 1 and branch office 2. Okay, and this is a internet service provider with a different autonomous system number. Okay, I usually connect this with OSPF, EIGRP, or BGP. I can do that any which way. So it depends upon how you want the routes to be, how you want to manipulate your path. Okay, I also can use OSPF here, I also can use RIP here, I also can use EIGRP here. Okay, so with BGP I can do the path manipulation. That's why I am using BGP as my exterior gateway protocol. But usually when organizations, when they have private network, okay, usually internally on your internal network you do use a private IP address, 10 dot network, 11 dot network, I'm sorry, 10 dot network, 192.168 network. These are all private network. But when you have to go out, you obviously have to use the public IP address. Okay, so whenever you connecting a different organization, we normally use BGP for path manipulation only. Okay, BGP gives you more advantage in path manipulation. That's the reason we use BGP. But on the MPLS and all that, we use OSPF as well. Okay, does that answer your question?
Yes, thank you.
No worries. Okay, let's go back to our lab. I'm starting R3. I'm starting R4. Okay, let's go to R1. Okay, I just want to connect to R1. I want to make sure no protocols are running. So how do I check? Is any protocol running? I'll give a command, show IP protocols. Okay, show IP protocols. I see that there is some protocol running, which is OSPF and which is BGP. So I do not want to use any protocol because I want to demonstrate to you guys. So I don't want any protocol to be used here. Okay, so I'll say, what is the protocol that is used? BGP 500 and OSPF 1. I'll just say configure terminal. No router OSPF 1. No router BGP 500. Okay, so this command actually takes off. It does take out all the protocols that is in use. Okay, now you might ask me, when you give no router BGP, so I did a configure terminal, no router BGP 500. Does that take off the protocol, BGP protocol? Yes, it does, because router BGP 500 is the command which starts BGP session in your router. No router BGP, of course, will end that session in your router. Okay. Similar way, no OSPF as well. No OSPF, no router OSPF 1. This command takes off the OSPF session. Okay. Now I want to erase all this. So I'll just go to router 2. I'll just paste the same thing. I'm just reducing my work. No router OSPF, no BGP. All right. Awesome. Okay. This is removed as well. Let's go to R1. Let's get on with the configurations. Okay. Now, if you see that S1 bar 0 should be configured an IP address of 1111. Okay. Let's see if it is configured or no. Show IP interface brief. Okay. The IP addresses are all pre-configured. I kept it pre-configured so that I can just demonstrate the BGP neighborship to you. Okay. So doing this IP configuration is quite kind of a, a little, it takes some time. So I just kept it already configured. So serial 1 bar 0 is configured with the IP address as shown in the diagram, and fast Ethernet 00 is configured with 10 LAN interface, and serial 11 is configured with 444442. Okay. And the loopbacks are also configured. I've kept all the IP addresses pre-configured. Okay. As you can see here. And the main thing to see is the status of this. Okay. The interface are up. So which means that I do not have a layer 1 or layer 2 issue. Okay. When the interfaces are up, I am good to go. I can actually proceed with my protocol configuration. Okay. Let's start with IBGP configuration. Now let's say, how do I start? I say configure terminal, router, BGP 500. Okay. Now I am on router 1. Okay.
Excuse me, sir. Can
Yeah,
you
sure.
make more larger font?
Oh, sure. Oh, this one, is it?
Yeah.
I'll just, okay.
If
Can you see it now?
possible, can you increase the font size?
Let me check. Is that possible? One second. I'm not able to actually. I don't know where it is. Not sure where it is. Any idea, guys? Any idea you have where it is to increase the font size? I tried to general and settings, but not able to.
Have you tried Control Plus if it will work?
Which one?
Control Plus.
That's right, but I have kept all the configurations done on this one. So, okay, maybe I can use that tomorrow if you want.
Yeah, you want to increase the font size, right?
Mm-hmm.
On that screen, try Control Plus. It normally works. I don't know if it will work.
Okay, let's see that.
I don't think Control Plus will work on the terminal.
Yeah, it will not.
Yeah.
I tried it. It is not working. Okay. So a full screen would do. I mean, is this okay, or like, do you want it to be more?
Actually, you can zoom it. Any other individual can zoom it from his end. So I think that will work. So you can zoom your screen if you want to see it clearly.
Okay.
Yeah.
Yeah, that's what I'm doing it. I'm zooming my phone and it works.
Okay. Okay, I'll find out a way, guys. Sorry about that. Let me do something tomorrow. By the time you get in, I'll do something. Make it bigger. Okay. So where were we? I was configuring router, configure terminal, router BGP 500. Okay. Now I want to actually show it to you by comparing the topology. That's the reason I'm just holding it down. Okay. Now on the router, I have to first select my neighbor. On the router one, what are the neighbors that I have? I have R2 and I have R4, right? So what I'll do, I'll use the WAN interface, that is 1.1.1.1, 1.1.1.2. I'll use these WAN interfaces to form the neighborship. Okay. Next, what we'll do, we'll use the loopback interfaces and form the neighborship. So today's task is using the WAN interfaces and creating a neighborship between them. So I'll say neighbor. Why do I say neighbor? Because always in BGP, the neighbor command is manually configured. Neighbor 1.1.1.2, and what's the remote AS? 500 itself, because we're configuring IBGP. Okay. Next, I'll say neighbor on the router one 4.4.4.1. Now, where is 4.4.4.1? It is connected to R4. Okay. It is connected to R4. So I want my R4 also to be my neighbor. So I'll manually type it as neighbor 4.4.4.1. Okay. And I'll say his remote AS as well is 500. 500. Okay. Then I have configured both sides. I've got my two neighbors which are directly connected to me. Okay. Now there is something that I want to advertise. There is something connected to me. Okay. There is something connected to me which I want to advertise. Which part is connected? The LAN interface or the LAN network coming in is 10.1.1.1. I have to advertise that. So I'll say network 10.1.1. I'll say network, advertise this 10 network. Okay. I'll just say 10.0.0.0, or I can still say 10.1.1.1 and say mask 255.0.0.0. This is how you advertise any interface on a router. Okay. This is how. Okay. Incorrect mask or network or mask configured. Okay. Let me go into show IP interface brief. Let's see what is configured. Okay. Network. Let me give a 10.0 network. No auto summary. Okay. Why we give no auto summary is because we do not want BGP to automatically summarize to the default mask. Okay. When I say 10 network, it doesn't mean that the subnet mask should be 255.0.0.0. Okay. Or when I give 192 dot address, the default mask should not be 255.255.255. Okay. So that is why I say no auto summary. It should not generalize it to the default classful mask. Okay. So this is about the router one. So in router one, if you want to see again what all I did, give a show run and then say section BGP. Okay. When you do a show run and section BGP, it will show you what all you have done on router one. Okay. This is what you've done in router one. That is no synchronization. BGP log, that is the command it automatically gives. So let's to show it in a notepad. Okay. On R1, you have done this. Network I'll remove this command. This is auto-generated. You have advertised the 10 dot network. You have done a neighborship with 1.2, and you have done a neighborship with 4.4.4.4.1. Now, similarly, I want to do it on R2 as well. So how was R2 configured? R2 is configured like, first I'll do the neighborship with 1.1.1.1 from R2. Okay. Now we are in R2. If you want to configure R2, the neighborship is 1.1.1.1, remote AS 500. That is right. That is the first command. Second command, 2.2.2.2. Your second neighbor is 2.2.2.2. Okay. Remote AS 500. What is the network that is connected to you? 20 dot network. So I'll say 20. Okay. I'll just go ahead, do a configure terminal. Okay. And I'll say router.
BGP.
Exactly. Awesome. Router BGP 500. And then I'll paste this. Okay. Looks appropriate, right? I'll paste this. Okay. Let's go to router 3. Now concentrate on router 3. 500. Now what are the two neighbors that I have on router 3? That is 2.2.2.1. Okay. Neighbor 2.2.2.1.
3.3.3.2.
Exactly. 3.3.3.2. And remote AS is again the same.
Same 500.
Exactly. Then I have a network. I'm advertising a network. What is the network that I'm advertising? The LAN interface. That would be this
30
one.
network. 30.0.0.
Right. 30.0.0.0. Okay. Awesome. Okay. That's all about router 3. Now let's go to router 4. Okay. When I go to router 4, I'll say configure T, configure terminal, router BGP 500. Then I have two neighbors again. What are the neighbors on R4?
3.3.3.1 and then 4.4.2.
Awesome. Neighbor 4.4.4.2. Okay. And also at the same time, think about the network that I have to advertise. What is the network that I have to advertise?
40 network, 40.0.0.0.
You got it. Lovely. So okay. Now we have done the configurations from our end. So we are done with the configurations. Now we have to verify it. So once you have, configured the internal BGP among the routers, you have to verify that. How do you verify it? So there is a command in BGP to verify the configurations as well. That is show IP BGP summary. This actually summarizes the neighbors that you have. Now, once you say enter, okay, it says BGP identifier is 11031. Now, why is the router ID 11031? Because it is automatically, even though I don't mention the router ID, BGP routers take the router ID as the highest configured loopback interfaces. Okay. If the loopback is not configured, say, then highest configured physical active interfaces. Okay. The first priority always goes to manually configured router ID. The second priority goes to the loopback interfaces, highest IP address of the loopback interfaces. Third priority goes to highest IP address of the physical active interfaces. Okay. That is how it works. So it says my router ID is 11031 because that is the highest IP address of the loopback. Now it says the table version is 4, local AS number is 500. Okay. You need not worry about this. You just can directly jump into this. You can see that the neighbor that you have configured is 1.1.1.2 and 4.4.4.1. BGP version that it's running is 4. AS number. What is the AS number? It is 500. Messages sent and received. Okay. It will also keep a track of messages sent and received in the table versions. Now, how many, from what time this looks up, this neighbor looks up? So it's been like 1 minute 59 seconds that I've configured this neighbor, and it's been like 46 seconds that I've configured this neighbor. And what are the prefixes, or what are the networks that you are getting from this network? From 1.1.1.2, I'm getting this network, 20 network, and from 4.4.4.1 I'm getting 40 network. That is why it says 1 and 1. If the neighborship is not up, how do you see it? Your question may be that. Your question may be, what if the neighborship is not up? How do I know? So instead of 1 or 1, it says active here. Active or idle or connect, different states of BGP neighborship, different phases. Okay. It might say active also, it might say connect also, it might say established also. So once it is established, it doesn't say established. Established meaning neighborship is up. Okay. It will actually advertise the number of networks from that one. Okay. Now the same command here, show IP BGP summary. Okay. It again shows you the same networks. Okay. 1.1.1.1, 2.2.2.2. Show IP BGP summary. Okay. Then here again, show IP BGP summary. I'm doing it in all the routers because I want you to memorize the command. Okay. So if I do it in one and just leave it at that, maybe you'll not be familiar with the command much. It will not be in your brain. So if I type it on all of them, why is this popping up? Okay. Show IP BGP summary. Okay. So to always, to always look at your neighbors, you have to do it. You have to give a command, show IP BGP summary. Now, one more thing we can do. What we can do is we can take this interface down, which is 1.1.1.1. Let's take that interface down, okay, and see what will be the result of the neighbor here in R2. Okay. Now let's go to show IP interface brief. Now let's go to interface. Where is that connected? So interface serial 1 bar 0, right? So I'll say configure T interface serial 1 bar 0. Okay, I go to the serial 1 bar 0. Okay, here it is. Okay, I'll say shutdown. Shutdown. Okay, when I say shutdown, obviously the the neighborship should be down. Obviously, right? Let's go to R2. Verify that. It is still not down because BGP, what it does, once the neighbor is down, actually it keeps sending hello packets to the neighbors. This keeps sending hello packets to the neighbors. If it does not respond within 10 seconds or 30 seconds, it will have a dead interval. So it keeps sending, see, once the dead interval is done, I am done with sending hello packets or keep alive messages. He is not responding to keep alive messages, so I'll declare him down. So when I do a show IP BGP summary, it will be declared down. Okay. I think it has now declared it down. It will take some time to establish the neighborship as down. Let's see on R1. R1 would have already changed it to down. Show IP BGP summary. It takes 30 into 5. I don't know about the dead interval. Let's do a clear IP BGP process, clear IP-BGP process, in the sense it will establish the neighborship from the scratch again. Okay. Once it established the neighborship from scratch again, it will see that this one is down, 1.1.1.1 is down. So there will be, you see that neighbor 1.1.1.1 is down. So the state, if the neighborship is not up, the state that will be displayed here is active. Okay. That is what I wanted to actually show you. So whenever there is BGP which is down, you always see it as active and not see it like this as one, like this. Okay. This is about the IBGP configuration that we did today. Okay. This is configuring internal BGP, which are in the same autonomous systems. Okay. This lab is actually useful. So this lab actually was one of the part of the lab. We have a big lab topology with us. I'll just show you that. So what happens if we so what is inline, what is in the pipeline? Actually, let me share that to you. In the pipeline, so today we have done this IBGP neighborship. Okay. So tomorrow, what we'll do is we can set up I mean today tomorrow again we can, you know, set up IBGP using loopbacks, and also we can set up eBGP, that is between two autonomous systems, using normal WAN interfaces and using loopbacks as well. Okay. And then let's see how the split horizon rule works, because now see, we have R1. So as I discussed with you about split horizon rule, we have R1, which is having 10.1.1 network. Okay. It will pass on to R2, but R2 will never pass it on to R3. You want to see that? I just have it. I just can show that to you. What I'll do is I'll do a configure terminal interface S1 bar 0, because I want to get that interface up. Okay. No shut. I want it to be neighbors again. Okay. So let me check. Okay. It takes its own time. So I don't want that to happen. So I'll do a clear IP BGP process so that it actually comes up soon. It'll reinitiate its neighborship process. It'll come up. Okay. Now these two are neighbors. Okay. These two are neighbors. I was actually talking about different tables of BGP. Now, when I do a show IP BGP summary, what do you guys think? Which table it belongs to? So there are three tables in every protocol. Okay. Neighbor table, topology table or database table, and a routing table. When I do a show IP BGP summary, it obviously displays the neighbor. So it is a neighbor table. Okay. When I do a show IP BGP neighbor, show IP BGP summary, this is a neighbor table because it gives the information about the neighbors and its status. Okay. This is a neighbor table. Now, when I do a show IP route BGP, what table it is? It is a routing table, right? What are the routes that I can see? What are the routes through BGP that I can see? Now, route is R1 is seeing 20 network. Who is advertising 20 network? Obviously, it's neighbor. I have set a neighbor relationship between R1 and R2. In R2, if we remember, we advertise a 20 network, 20 dot network, right? That has been advertised to R1. Okay. But is R1 further advertising that to R4? Let's see. Let's go to R4. Show IP route. Show IP route. BGP. See? The 20 network learned from R2 is only learned and kept in the routing table of R1. But R1 is not even passing that 20 network to R4. When you do a show IP route BGP on R4, you never see a 20 network. Okay. This is because of a split horizon rule. Split horizon rule does not allow you in internal BGP to pass on the network, or an update learned from one BGP neighbor cannot be passed to another BGP neighbor. That is a split horizon rule. Okay. So that is a nice thing to know. I mean, those are the nice things to learn for today. Guys, you have any question for today's class? You have any questions, or do you have anything to ask?
Yeah, when will be the next session, and are they only on Saturday and Sundays, or what days is it going to be on?
Yeah, next free webinar session will be tomorrow. So that is the only session we'll have. So I'm actually conducting 2 free classes, 2 free webinar sessions. So after that, we'll actually directly start with the CCNP classes, where we discuss about all the protocols, and we do the labs for all the all the protocol labs, and also we discuss many scenarios, troubleshooting scenarios and all that. So tomorrow we'll have the class at the same time, in the sense we're doing right now, doing it on 8 to 9:30. Okay. And in your chat also, there is a there is some a note uh, given by the network journey, that is my institution. So you can check that. If you're interested in further classes, you can actually contact them, or talk to them. So tomorrow we can have those classes. And tomorrow in the pipeline, let me also tell you what all we got. Tomorrow we are configuring using loopback interfaces. So today we have actually established BGP neighborship using this WAN interfaces, right? Directly connected interfaces. But tomorrow, let's do it using the loopback interfaces. We'll see what difference does it make using the loopback interfaces. Okay.
I got one other question. Is there a way to view the recording for this session?
I think, yeah, I mean, so you can contact that, the contact details have been given to you. So once you ask them, so they'll definitely provide you provide you a way, or there must be a way of, they can actually sort it out. They can let you know how to, take this recording or something like that. So you can contact that number and they'll help you on that further. Okay.
Thank you so much.
All right.
I have one question, please.
Sure. Go ahead.
So, in CCNP course is also part of LAN, WAN also? Virtual LAN, VLAN.
That's right. VLAN. That's right. It is a part of CCNP as well.
Rahul, I have one query.
Encore and NRC?
Mm-hmm.
Or just one of them?
No, it's both Encore and NRC.
Oh, okay. Thank you.
Rahul, I have one query. Can I?
Sure. Go ahead.
So my query is like, let's suppose in a scenario where we have 2 ISP links which are connected through BGP.
Okay.
So like one of them is a primary and other is, let's say, backup. So is there any way in BGP like to auto shift the traffic when there is a failure in primary link?
Definitely you can do that. So you have 2 links, okay, to one of the ISPs. Okay. You have first ISP and second ISP. So what you can do is, not only in BGP, you can do it either, if not using BGP also, you can do that. So imagine you have 2 links here. Let me draw that and show it to you. See. That's my pen. Okay. See, you have 2 networks here. Okay. This is an ISP. Okay. This is an internet service provider. You have 2 links. One is a active link and this is a backup link. Now what you do a default route. Any default route, go to this 1112 IP address. This is like, let's assume 2222. Okay, this is 11112221. Okay, any address, any mask, go to this 1.1.1.2, and you give this default route an administrative distance n. Give this, mention another default route and show it to 2.2.2.2 and write it as the administrative distance is 20. Once this is down, it will automatically pick up this default route and go to this backup link. Right?
Yes, yes, correct. But in case of BGP, like we are advertising on the network through BGP, then
exactly, through, in case of BGP also you can do that. So you can actually prioritize the path. Okay, so if you can actually use the attributes, BGP attributes mainly, you can use the BGP attributes. So there are set of BGP attributes to actually do path manipulation. You can definitely use one of those attributes and actually manipulate the path, decide which you actually want the path. Okay.
got it, got it. Thanks, thanks.
Excuse, please, can I ask a question?
Yeah, sure.
Excuse.
Go ahead. Go ahead.
Please, since I don't know, maybe I just joined this group now, so I don't know, maybe I can just get a brief explanation, like summary of what we did today, because I heard the video might not be gotten, the record video cannot be. Can you please summarize for me?
Yeah, no problem.
Please.
So today what we learned is we learned about BGP. So BGP, in the sense, what all are what are all included in BGP? Autonomous system. What is an autonomous system of BGP? And how do you connect BGP to internet? What are the options and what are the features of BGP? So how BGP reacts, and what is internal BGP and external BGP? Okay, these are the things that we learned. And also we did a lab today. In the lab, what we learned is we actually learned about how connecting to internal BGP routers, in the sense, in the same autonomous system, using WAN interfaces. Okay, these are the things that we learned. And guys, this is our lab. Okay, our lab setup. As you can see my mouse hovering over it, this is a small part of the lab that I've taken and I've demonstrated it to you. Okay, this is our entire lab topology. Okay, and you will be getting around 6 months free lab access. Okay, once you enroll to this course, you will be having access to this lab for like 6 months. This is the whole lab that we have. Okay, so if you got any doubts or any questions, you can ask me. I'm there for more 10-15
So
minutes.
I will go through it. So if I have a question, I will just catch you up. Thank you very much. Thank you very much.
Thank you so much, everyone. Any questions? I'll be there for more 5 minutes. If you want, I can spare some time for you.
I have a little question there.
Okay.
Can you go over the content, the syllabus of the
which one?
course? You know, the one that you had on the PowerPoint. Can you go over that again?
Oh, you want me to go through the PowerPoint, which I have?
The one that where you explain all the content that you will be talking about in the course of the CCNP.
That's right. You want me to go through this PowerPoint?
Like a little, yeah, quickly.
Yeah, sure. Sure. So you can keep a record of it, not a problem. So we learned about introduction to BGP. What we learned is autonomous systems, iBGP and eBGP protocols, basic eBGP features, BGP features. What is the loop prevention mechanism, both in iBGP and eBGP, and when to use BGP? Okay, those are the things that we learned. What are the IGP protocols, BGP protocols? What is the loop prevention mechanism? And when do we use BGP? BGP options on the internet, connecting to BGP with the internet, and also understanding the neighborship. Understanding the neighborship in the sense, iBGP neighborship, using WAN interfaces. Okay, and what are the BGP tables that we saw today? Okay, those are the things that we went through. And one more thing I would like to show you. This is our workbook that we have. Okay, just 1 second. This is a workbook that we have, Encore and an NRC workbook. I'll just go through it. I'll just go over it. I'll just keep scrolling down. You can see those labs and all that. Okay. These are the labs that is there in the workbook lab. Okay. And with the commands as well, they've mentioned the topology, and I've mentioned the commands one by one as well. So it will guide you in a proper way, precise way, how to configure and how to understand the lab. Okay. These are the configuration along with it. It seems to be very helpful. It has every command. Even if you go wrong anywhere, you have the command here to help you. Okay. That's it for today I have, but I would like to thank you all for your time. Thanks a lot for your time today. If you have any more questions, you can ask me.
Rahul, I have one more query.
Sure, go ahead.
Like general regarding MPLS and internet link, like so MPLS is generally using a private IP address space or public, or can use both?
MPLS you can use private as well. Usually they are used in MPLS. Usually people use private IP addresses. Okay, so when you use private IP address, because what in MPLS basically you're using MPLS to actually connect your branch offices. Okay, you need a tunnel which connects to your branch office. So when I use a private IP address in my one office, the same private IP address should be known in the other office as well, right? For internal connection. So we use private IP addresses over a tunnel. We send those private IP address routes over a tunnel to the other branch offices.
Yeah, got your point. Thanks.
Thank you, guys. Have a good
Is
one.
there any study guide, CCNP study guide that you suggest?
Definitely. You would be getting an advanced study guide from my institute. So you will be getting all the workbook, along with the access to the lab. You will be getting advanced study materials as well, which is up to date, and which is having the recent syllabus as well.
It means we don't have to buy GNS3 and Cisco iOS images.
So I mean, it's up to you. So if you want to keep practicing the lab on your own, you can do it. But if you want to practice lab for 6 months, we'll take care of that. So we are there to help you with that. So for 6 months, you would have free access to the labs once you enroll it. Okay, you would have free access, and you can get on the lab and do do the practice whenever you want within 6 months. So after that, if you need something, you have to go with GNS3 or something. All right.
Is it going to be a weekend class, Rahul? How it would be the live classes?
We can set it up depending upon the crowd or depending upon the people. So depending upon their interests. So however comfortable for them. So we can keep it either in the weekend. Let's see which area most people are interested, which timings most people are interested. So depending upon their timings, we can sort it out. And but for now, from my end, I have both open. Weekend morning batch. So as he says, it would be a weekend morning batch. I think it's probably going to be a weekend morning batch. Let's see. So which you guys are interested in, weekend or weekday batches? Usually it'll be a weekend batch, I heard.
Yeah, yes.
Okay. Is that it, guys?
thank you for your time today, Rahul, showing us about split horizon rule and BGP neighborships.
No worries, no worries. Always welcome. Thank you, everyone. Have a good day.
Thank you very much. See you tomorrow.
Thank you.